morning. I'm Ankit Mishra, research scholar of Maths University, Chhattisgarh, India. My co-author is Dr. Manoj Kumar Nigam. My research work is theoretical analysis of tandem solar cell doped with MASNI3 with P3STPCBM active layer. My track of the paper comes under renewable energy resources and the technology with a paper ID of 1584. The content of the presentation includes the introduction, peroxide solar cell, objective of the research work, materials and method, mathematical model, results and discussion, conclusion and references. So we'll start with the introduction part. So as we all know that due to the increase in the pollution, the greenhouse effect gases and the high cost fossil fuels, the world demands a new alternative resources in which the photovoltaic, the solar cell plays one of the prominent role in the present generation. In this solar cell, the perovskite has gained the prominence material or the panel which is highly used in the present time as a research part. All over the researcher from the globe are doing constantly research on this perovskite based solar cell. The perovskite solar cell has a high light absorbing layer which is the other promising material, which is having another best part is that it has a high efficiency and the low production cost. In terms of the traditional peroxide solar cell, CH3 and S3PBI3, here we are using methyl ammonia tin iodide as a peroxide layer to enhance the performance and stability. Not only this, this particular material also helps us to improve the absorption coefficient and the carrier mobility, which lead to the higher power conversion efficiency of the solar cell. The objective of my research work is to analyze a different structure to increase the conversion efficiency, to analyze the stability of the structure, and to improve their performance and viability. The materials and the method I am using here is shown in the figure number 1. My structure is based on the PIN solar cell in which I am using glass ITO as an active transparent layer, P.PSS as a whole transportation layer, P3STPCBM as an electron transport layer, MSNI3 as a peroxide layer, and AL as a counter electrode. The MaSni3 is one of the most prominent material which absorbs the sunlight and convert it into the electricity. It is having a high efficiency and a low cost, which makes it a promising alternative for the silicon-based solar cells. This solar cell is having some challenges and issues which needs to be improved later on. The issue basically deals with the stability of the structure. The second material I am using here is P.PSS, which act as a conductive polymer, which is also a whole transporting layer, which has higher efficiency of enhancing the whole collection and transport. The third material, the main material I'm using here is PCBA with the combination of interfacial defect material like P3ST, which enhance the electron transport property in the peroxide solar cell. This is also used to enhancing the overall cell performance stability. The mathematical model here I'm using is Lyman recombination model, which is basically explains the charge carrier recombination of hole and electrons, which is based on the rate of recombination rate to the square root of the carrier concentration. With the Lyman recombination, I am also using the equations, Poisson equation, continuity equations, with drift diffusion equation, and the recombination and generations model. In figure number 2, as you can see that I'm using the parameters of the different material which is listed here in this figure number 2. Now come with the result and discussion part. As you can see in figure number 3, I have simulated 3 different structure with 3 different ambient condition. The first is AM 1.5, second is in a normal condition that is nearly about 273 to 300 degrees Celsius, and the third under in the sun condition in which I am getting the efficiency nearly about 30%, under the sun condition. And without the sun condition, I'm getting the efficiency nearly about 15%, 10 to 15%. In figure number 4, as you can see the generation rate versus the light. So in terms when the light is high in peak form, the particular generation rate of electron is very high, which is nearly about 2.5 to the power 34 electron. It comes in the nanometer scale of 400 to 500. In figure number 5, you can see the quantum efficiency and the wavelength chart, where when under the in sun condition, the quantum efficiency of the structure is very high compares to the normal condition and AM 1.5D condition. The quantum efficiency with respect to the previous conditions we are getting here is 110% high. In figure number 6, we can see the generation of electron or the movement of the light from one point to another point in a equal distribution way. The conclusion of my presentation is we have successfully gained and achieved the efficiency 27.8% by using the glass and ITO, which increase the quantum efficiency of 110%. Under sun condition, the efficiency is very high, and in the 500 nanometer scale, the quantum efficiency reached to its maximum point. The main result and insight of this structure is we have achieved the great stability as well as the quantum efficiency is very high in the specific 500 nanometer scale. The analysis also provides the insight into the structure behaviors and the photon related characteristics. And in my future work, we are going to be work definitely on more stability materials so that this particular efficiency will increase from 25.7% to the 40 or more than 40%. So we are using different structures material. We are using working on different material which can enhance the property. So my reference are here. I'm using the specific papers and the literature survey to work on this model, which is listed here. If you have any questions and if you have any problems, you can ask me. Thank you. Thank you from my side.